Hello everyone, you're welcome to this tutorial. And in this tutorial, we're going to discuss the powers of sine and cosine in relation to basic integral calculus. So how we are going to do this session is that we are just going to consider some questions under powers of sine and cosine. Now, let's consider this question. If we are told to evaluate integral sine square x dx. Now, if you are to solve this question, firstly, we have to evaluate sine x. We know that integral sine x is going to give us minus cos x. But now, this is no more sine x. This is sine square x. So which means sine x times sine x. So how do we solve this? Now, we have to go back to our trigonometric identities. We know that sine square x plus cos square x is equivalent to 1. And we know that cos square x minus sine square x is equivalent to cos 2x. Now, if we sine 2x, that will be 2 sine x cos x. So here, since we want to make sine square x, since we want to find the integral of sine square x, we are going to look for a function that is just going to have sine square x as the subject of formula. Then every other thing that we have here, we are going to substitute something else. And that something else is not just anything. We are going to derive it from this identity. Now, if we take a look at the fundamental trigonometric identity that we have, sine square x plus cos square x equals 1. If we decide to make cos square x the serial formula from this second trigonometric identity, we are going to have cos square x to be equal to cos 2x plus sine square x. So now, if cos square x is equal to cos 2x plus sine square x, if we put this in equation 1, it means that sine square x plus cos 2x plus sine square x will give us 1. So here, sine square x and sine square x, they are like terms. We can add them together. We'll have 2 sine square x to be equal to 1 minus cos 2x. If we make sine square x the subject of formula here, sine square x will give us 1 minus cos 2x divided by what? Divided by 2. So now, since we have gotten our sine square x to be 1 minus cos 2x divided by 2, it means that integral sine square x dx is now the same thing as integral 1 minus cos 2x divided by 2. So here we have 1 minus cos 2x divided by 2. So if we use the 2 to divide 1 and cos 2x, this is going to give us 1 divided by 2 minus cos 2x divided by 2. So everything with respect to x, which is dx. So this is the same thing as integral 1 over 2 dx minus integral cos 2x divided by 2 dx. So basically, this is going to give us, if we integrate 1 over 2 with respect to x, that is going to give us 1 over 2x. Then minus, we can factorize 1 over 2 from this cos 2x, so which will be 1 divided by 2 integral cos 2x dx. So don't forget, if you are to integrate cos 2x, I don't want to skip any step here. If you're going to integrate integral cos 2x dx, you can use just basic substitution. If our u is equal to 2x, then it means that the u dx is going to give us 2. So it means that integral cos 2x dx now will give us integral cos 2x is now u. Our dx, if you make dx the sort of a formula here, you're going to get du over 2. So it means, that is, if we cross multiply here, you know that this is going to give us du is equal to 2 dx. So when you now make the x0 formula, you divide both sides by 2, dx will give you du over 2. So I'm now substituting it for that dx. So here, if we factorize 1 over 2 out, this will give us 1 divided by 2 integral cos u du. So we can integrate cos u with respect to u. That will give us 1 over 2. Integrate cos, you get sine plus arbitrary constant c. So don't forget our u is 2x, so that will be 1 over 2 sine 2x plus arbitrary constant c. So it means here that integral cos 2x dx is 1 over 2 sine 2x. So this 1 over 2x minus 1 over 2 times 1 over 2 sine 2x plus c. So essentially this will give us 1 over 2x minus 1 over 4 sine 2x plus c. So which basically is x divided by 2 minus sine 2x divided by 4 plus an arbitrary constant c. So, and this is going to be the final answer to this question. So it means that integral sine square x dx, when you integrate it, you're going to get x over 2 minus sine 2x divided by 4 plus an arbitrary constant c. So we're going to take another example now. In this next example, we'll take it with respect to another trigonometrical identity, still in the powers of sine. So for the second example, let's assume that we are to evaluate integral cos square x dx. So the powers of cosine, but we raised to a power of 2. So we have integral cos square x with respect to x, which is dx. So we're going to use the same approach. Remember, our fundamental trigonometrical identity is sine square x plus cos square x is equivalent to 1. So here we are trying to make cos square x a representation for cos square x. So let's make sine square x the set of formula. Sine square x as subject of formula will give us 1 minus cos square x. So don't forget cos square x minus sine square x is equal to cos 2x. So anyway, we see sine square x, we substitute 1 minus cos square x. So this will give us cos square x minus 1 minus cos square x is equivalent to cos 2x. So here we have cos square x minus 1 plus cos square x is equal to cos 2x. So if we collect like terms, we are going to have 2 cos square x, that is cos square x plus cos square x, minus 1 is equal to cos 2x. So what it means is that 2 cos square x will give us 1 plus cos 2x. So cos square x basically is the same thing as 1 plus cos 2x divided by 2. So if cos square x is the same thing as 1 plus cos 2x divided by 2, it means that integral cos square x is now the same thing as integral 1 plus cos 2x divided by 2 dx. So same approach, let's split the same thing as integral 1 over 2 dx plus integral cos 2x over 2 dx. So if you integrate these, this will give you 1 over 2x plus. So now this 1 over 2. If we factorize 1 over 2 out, if we integrate cos 2x, we are going to get sine 2x over 2. So this will be times sine 2x over 2. So indefinite integral plus an arbitrary constant c. So we have x over 2 plus sine 2x divided by 4 plus an arbitrary constant c. And that is going to be the final answer. So we're going to move to another example now. So in the next example, we are to evaluate integral. I think this is example 3. Example 3. So we are to evaluate integral sine square x cos x dx. So we are to evaluate integral sine square x cos square x dx. Now we are going to use application of substitution here. And for this question, to use application of substitution, the one that is raised to wants to see either sine square x cos x dx, or you see cos square x sine x dx. The one that is in the powers of 2, you take it to be your u. That's what you're going to substitute. So in the process of substitution, you understand why we're actually doing that, because there's a derivative relation between sine x and cos x. You know, when you differentiate sine x, you get cos x. When you differentiate cos x, you get minus sine x. So it makes it very easier for you to, by substitution, you will be able to integrate it by substitution. So we'll say that to be let u to be equal to sine x. So if u is equal to sine x, we know that du dx is going to give us cos x. So since du dx is equal to cos x, it means that dx is going to give us du divided by cos x. So the question now can be simplified as, since u is sine x, sine square x will give us u raised to the power of 2 multiplied by cos x times dx. And our dx now is du divided by cos x. So you now see why we took u to be equal to sine x, because you discover that cos x here is now going to cancel cos x. So I know that's the aim of substitution. Actually, you're trying to substitute something that will be able to cancel what you have with the second derivative function. So here, cos x will cancel cos x. You are going to be left with integral u square du. So we know that when we integrate u square, we're actually going to get u raised to power 3 divided by 3 plus an arbitrary constant c. So and we know that our u is sine x. So u raised to power 3, that is when u is sine x, this is basically going to give us sine cube x divided by 3 plus an arbitrary constant c. So it means that when you integrate sine square x cos x dx, you're going to get sine cube x divided by 3 plus c. So let's take an example 4. Let's reverse the case. Let's say we are to evaluate integral cos square x sine x dx. So let me say example 4. We are to evaluate integral cos square x sine x dx. So same approach, we'll say u is now equal to cos x. So it means that du dx is going to give us minus sine x. So since du dx is minus sine x, if we make dx a sort of formula, dx is going to give you du divided by minus sine x. So what it therefore means is that the question now can be written as integral cos x is u, so cos square x will give us u raised to the power of 2 multiplied by sine x multiplied by dx. Our dx now is du divided by minus sine x. So sine x, we cancel sine x, we will be left with minus 1 here. So we can just factorize that minus 1 out. So that will be minus 1 integral u square du. So this minus 1 multiplied by if you integrate u square du with respect to u, that will give you u raised power 3 divided by 3 plus an arbitrary constant c. So our u is cos x. So this is basically minus cos cube x. That is when u is equals cos x divided by 3 plus an arbitrary constant c. And that will be the final answer to that question. So we're going to take two more examples. We're going to take integral sine cube x dx, and we're also going to take integral cos cube x dx. So that will be example 5. So for example 5, we are to evaluate integral sine cube x dx. So we are going to use the approach of the first form that we did, which was that first form was when we are to evaluate something like integral sine square x dx. So, but we are, let me put it in this form. You know that a raised to power 3 is the same thing as a squared times a. So it means that if we have sine cube x, we can derive sine square x out of sine cube x. So using this representation that I have here, it means that integral sine cube x dx can still be represented as integral sine square x dx. Integral sine square x multiplied by sine x dx. So from that trigonometrical identity, don't forget, we know that sine square x is the same thing as 1 minus cos square x. That's from your fundamental trigonometrical identity. So, okay, let me just write that down. Sine square x plus cos square x is equal to 1. So it means that sine square x is the same thing as 1 minus cos square x. So basically what this means is that integral sine square x sine x dx will give us integral sine square x is 1 minus cos square x multiplied by sine x dx. So this will give us integral, if you open the bracket, sine x times 1, that'll give us sine x minus sine x cos square x with respect to dx. So this integral sine x dx minus integral cos square x sine x dx. So don't forget sine x times cos square x is the same thing as cos square x times sine x. So if you integrate sine x, you are going to get, if you integrate sine, you're going to get minus cos. So that will be minus cos x minus, if you integrate cos square x sine x, don't forget that's what we did earlier. That is minus cos cube x. So since we have another minus, so this will just be plus cos cube x divided by 3 plus arbitrary constant c. So it means that when you integrate sine cube x dx, you're going to get minus cos x plus cos cube x divided by 3 plus c. So final example, let's treat it in terms of cosine. Example 6, integral cos cube x dx. So in terms of cosine, this same approach, this will be integral cos square x cos x dx. So this integral 1 minus sine square x cos x dx. So this will give you integral cos x minus sine square x cos x dx. So this integral cos x dx minus integral sine square x cos x dx. So if you integrate cos, you're going to get sine. So this will be sine x minus, when you integrate sine square x cos x, you're going to get sine cube x divided by 3. We have done that example. So this will be sine cube x divided by 3 plus an arbitrary constant c. And that's going to be the final answer to that question. So basically, those are basic integral questions under powers of sine. Uh, if you have any question, you can drop it in the comment section. Once again, this is Peter from Learn with Uncle T, and see you in the next tutorial.